Hi, this is Jill. Welcome to another episode of SalesianaBooks channel. Oh no, I'm late! I need a quick ride going to Makati. I hope there's an available car to pick me up. Yes! There's one near! Booked! It's amazing how recent advancements in science and technology have made it possible to locate anyone or anything anywhere on our planet in an instant. The Global Positioning System, or GPS, made it all possible. In this age, people all over the world are connected through one large network, the World Wide Web. Airlines use a unified system for booking passengers, scheduling flights, and tracking baggage. Banks around the world are linked into a global banking system. The world that we know today is globalized and unified more than ever. About 200 years ago, it was very difficult to even get an accurate distance from one point to another because there was no standard unit of measurement. During the time of King Louis XVI, France alone had 700 to 800 differently named unit of measures and weights that simultaneously existed. It hampered economic progress. Trade and commerce were slow and cumbersome. Take, for example, pint. It had different corresponding values depending on the location. France was then in the throes of the French Revolution, which had begun in 1789. Still holding on to power, Louis XVI on June 19, 1791, met with a committee of 12 mathematicians, geodesists, and physicists to grant them his approval to construct a new system of measurements that will define length, volume, and mass. 1 year later, Louis XVI issued a proclamation that ordered several scientists, among them Jean Delambre and Pierre Machine, to perform the tasks needed to determine the fundamental unit of length in the new system. It was to be called a meter, from the Greek word metron, meaning measuring stick. For this reason, the whole system that will be derived from the meter became known as the metric system. This is a meter stick. It took 6 years to determine the length of the meter that we use today. The committee of 12 scientists and mathematicians have agreed that the unit of length would come not from a human body part like the foot or the palm, nor from an artifact like the length of a stadium. Rather, it should be natural, permanent, and repeatable. Earth. Earth is a natural object. The unit of length should come from the size of the Earth itself. Thus, Machine and Delambre were instructed to determine the length of the quadrant from the equator to the North Pole. That's 1/4 of the Earth's circumference. After years of arduous work, the committee finally knew the length of the Earth's quadrant by measuring only a portion of the quadrant, the distance from Barcelona, Spain, to Dunkirk in northern France. From the value of this distance, the length of the quadrant can be determined mathematically. If you get a hold of a meter stick, what you have is 1/10 million part of the Earth's quadrant. If you have been following the discussion, the circumference of the Earth is 40 million meters. Since the meter as it is will be too big to make small measurements, it was divided into 10 parts. You can see all these divisions of decimeter, centimeter, and millimeter on your usual ruler or meter stick. The Merriam-Webster dictionary defines capacity as the ability to hold or contain. It normally refers to the amount of space inside solids or three-dimensional figures. This is known as volume. The unit of volume in the metric system was derived from 1 decimeter by 1 decimeter by 1 decimeter, or 1 cubic decimeter. This was named the liter, from Old French litre, meaning measuring container. The original definition of the liter was the volume equivalent to the volume of a cube, with each side having a length of 1 decimeter or 10 centimeters. But a liter doesn't have to be a cube all the time. Today, it appears in many shapes. What's important is that the space within the container is 1,000 cubic centimeters. The standard volume, the liter, was to be filled with a natural and easily available liquid substance, water. That amount of mass found in 1 liter of pure water was to be the standard mass, originally called the grave, but later a law renamed it to just one generic term, gram. With the 3 basic units, meter, liter, and gram, the metric system became an established fact. This was through an act of legislation by the French National Assembly on June 17, 1999. The motto of the new system was, "For all people, for all time." The original fundamental units expanded into a whole system of quantities and units that cover mathematics, science, medicine, nutrition, engineering, manufacturing, and industry. The definitions of the units have also changed. The metric system was officially adopted for all of France. It spread through Europe through the conquest of Napoleon Bonaparte. From Europe, the metric system steadily spread to other continents. In an international assembly held in 1960, the metric system officially became the Système International d'Unité, or SI. Today, 99% of the world officially uses the SI. Spain adopted the metric system in 1852 and introduced it to the Philippines in 1860. The Philippines was officially made to adopt SI during the martial law period. President Ferdinand Marcos vested all lawmaking powers upon himself when he declared martial law on September 21, 1972. On May 10, 1973, he issued Presidential Decree Number 187, which established the use of the metric system of weights and measures as the standard measurement for all products, commodities, materials, utilities, and services, and in all business and legal transactions. A second Presidential Decree Number 748, issued on July 16, 1975, made the metric system as the sole standard of units and measures in the Philippines. The English units, as well as the old Filipino units, gradually gave way to the metric system. 43 years after Presidential Decree Number 187 was implemented, the Philippines is now part of the global system of measurement that was envisioned by its creators as a system for all people, for all time. Quality education through quality textbooks.